Okay, fine. Hi all, good morning.
Hi, good morning.
Fine, I think we should start now. Okay, before proceeding, any questions, any clarification you're looking for, any confusion, or any topic on which you want to discuss, please tell me. Okay, fine. Then let's just start. So in the last class, we have discussed about OLAP, OLTP, uh, data warehouse, database concepts, and we have seen a relation between OLTP data warehouse and database. And I think good number of points we have discussed. We have seen differences as well. And I think those points are more than enough. Okay, if you're going to crack an interview. So go through those points again because those points are very important from interview perspective or whether you're working in a project. So you should be having those understandings. Okay, fine. Okay. Mm, So now proceeding with dimension and fact and star and snowflake schema. Okay. Uh, Fine. Yeah. So this is star schema. Okay. Before this, no, I want to show you some example. Then I think this will be more easier to understand. Okay. I hope all are there. You guys are able to hear me, right?
Yeah, yeah, yes.
Okay. Try to understand this. The star and snowflake schema. They are very important from interview perspective, or if you're working in a project, you should have this knowledge because if there is a discussion going on in a project about star and snowflake schema, dimension and fact tables, then you should know this what this is all about. Okay. Okay, so I have started this day before yesterday. Try to understand this and stop me if you want to stop any point of time. I'm trying to make you understand from my example. Okay. So there is an ABC College of Engineering. Okay. And they have approached us to design a data warehouse, a database for their college. Okay. They approached us to design a database or data warehouse for their college. Okay. Now in their college, they'll be having multiple branch. So for the timing, we have assumed they have EC branch, CS, mechanical, civil, biotic, computer, chemical engineering, IT. Okay, these are the 4 or 5 branches we have assumed they have. Okay, and and in each and every branch you have HOD ID, right? So EC branch you have HOD ID one. I've assumed that in EC branch the HOD name they have ID as one, and his name is Rajkumar. In CS branch, HOD is Shruti, and her HOD ID is 2. Similarly, for mechanical, HOD name is Raman and HOD ID is 3. And similarly for other branches as well, we have HOD name, we have HOD ID. You might be thinking that I have kept some spaces blank rows here. So this is intentionally, and I will tell you the reason for this. Okay. Hope so far this is clear. In ABC College of Engineering, we have 3 columns we have designed now. We have branch, HOD ID, and HOD name. Okay. Different branches I have taken and the HOD name and HOD ID. Okay, fine. And then we have a column contact number of HOD. So randomly I have taken some numbers. So this is the contact number of Rajkumar. The HOD ID is 1 and who is the AC branch. Similarly, Shruti, contact number is this, HOD ID is 2 and all these things. Then we have a column address. Okay, address means where they belongs to. So Rajkumar belongs to Delhi. Shruti is from Kolkata. Raman is from Chennai. Abdul is from Hyderabad. Maybe like that. Okay. Is this fine? So far, so good. Till here, you understood what I'm trying to maintain? So at least every college, if they have to design a database or data warehouse, then they want this basic informations, right? Okay. Now, in each and every branch, you'll be having multiple semesters, right? So for the example, EC branch, I have taken 8 semesters, 1, 2, 3, 4, 5, 6, 7, 8. In EC branch, we have 8 semesters, okay? And the subjects are, okay. And in semester 1, we have subject A, B, C, D, E. Suppose this is F, F, and this is G. Okay. Semester 1, I have how many subjects? 7 subjects. Generally, we have 5 to 6 subjects. So I've taken 7 subjects here. Okay. And in each and every subjects, you have a teacher name. Okay. And each and every subjects, there is a teacher or facilitator who is handling this. Okay. So there's a teacher name as well in this. So subject A is handled by Rahul and his teacher ID is 101. You can also tell that this is employee ID or whatever you want. Okay. Suppose subject F is taken by Ramesh and his teacher ID is maybe something 601 or maybe anything. Okay. And subject G is taken care by Parag. Okay. So subject ID is teacher ID is 101. And we'll be having teacher contact number like this. So it will be there. Hope you understood from here to here. So here you have branch. Each and every branch they have HOD name and they have HOD ID, contact number of HOD, address. And then each branch, you have multiple semesters. I have included those information as well. And each semester, you have multiple subjects. Each subject, you have teacher who's taking care of those subjects, who's teaching their subject, and teacher contact number, right? So far, any confusion, guys? Clear? Is it clear? Okay, okay. It's clear. There was a shortcut to insert multiple rows. I forgot that shortcut.
Control Shift Plus.
Sorry, your voice is not audible. Hello, hello.
It's Control Shift Plus.
Control Shift Plus, no? Okay, just a minute. Control Shift Plus. No, this is not working. Control Shift. There is plus, 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 plus. Correct. Very good. Perfect. Thank you. Thank you. So now in semester 1, just a minute, guys. Okay. Now in semester 1, you'll be having multiple students. Okay. The first student is subject is student is B is one student, B is one student, one student. Okay. So in semester 1, these all are students. These all students are studying in semester 1. Okay. I think my battery is going down. Let me check. 49% is there here. So fine. In semester 1, I have these students, and for these students, I'll be having a student ID, a student gender, and all those things. Student location, marks, and all those things. Okay, fine. These are informations. Marks is scored. These values will be there. Now try to understand. For one branch EC, for one semester, I have these students, right? and I have taken only 9 students. So maybe you have generally 30 to 40, 50 students in one semester. And then in second semester, similarly, I'll be having multiple students details will be coming here. Third semester, multiple students details will be coming here, right? Fourth semester, similarly. And this was all about EC. If you're moving to CS branch, again, you have to add entry for each and every semester and the students who are studying in each and every semester. Is this clear? It is a bit hectic to draw all those things as of now. Hope you can understand. Okay. So, but can you realize the complexity of the table? Can you realize it? It will be too complex, right? And it will be very hectic for anyone to look into this table. You can understand this, guys?
Yeah, clear.
Yeah.
Okay. So now you can see it is getting complicated. Okay, and I think if anyone will look into this, table, single table, so they will think, okay, this is very complicated. Right? I do understand they can draw, they can understand what information is there, but this will be a little bit complicated. I have not drawn all the data, I have not inserted all the data. This will take a good amount of time, but hope you can realize, you can visualize it, right? That how much complicated and hectic this will be, right? So this was scenario one. This is the one way through which I thought of designing a database of ABC College of Engineering, and I will hand it to them that, okay, this is the table I have designed. From this, you can get all the information. Okay, this is one way. Okay. Then you have another way. Guys, please stop me if you want. I'm not in a hurry. This is a very important concept. So you should know this clearly. Any confusion, please let me. Now, this is second technique through which I'm trying to design that database. Okay. Here, what I have done is I'm working in chunks. Okay. I have designed a separate table for branch only, and this will be having branch ID and branch name. Branch ID1 EC, branch ID2 CS, mechanical, civil, IT, or whatever you have, you can add all those things. Okay. Then I've created a separate table HOD. In this, I'll having HOD ID, HOD name, their location, whatever it may be, contact. The more address was there. No, I think no, this is not required. We keep it here. This is not required. We use this. Okay, fine. So this is the one which I have designed here. So HOD is over, branch is over. Then what I have, address, location address I mentioned, contact number. And then you have semester, right? Semester and subjects. Then what I will do, then I will create a separate table, teacher. Okay. And this will, in this table, I will keep teacher ID. Okay. Teacher name. Teacher ID and teacher name. Teacher ID, teacher name, teacher contact number. And teacher contact. Okay. Now in this teacher table, teacher name is Rahul and you should know those things. Keep it here. This one. Teacher ID is 101, something like that. I have here. Teacher ID 101, 201, 301, 401, 501, 601, 701. Okay, and there might be some contact number as well here. Okay, this is the contact number. Fine, this is a separate table. And then you'll be having then I will be having a student table. then the student table. In this you have student ID, student name, student contact, location, and marks. So maybe I can copy from here. I can give the details of the student as well. Students, was students name? These are the students. And their IDs, maybe whatever it may be. Suppose 303, 345, something like that. Okay. IDs. And gender and all those things there. Now, this is one way. This is second way that I will creating a separate table of branch. Then one for HOD and one for teacher and one for student details. Okay, now let me give this in a table. Okay. Now then I will create a score table. Fine. In this score table, I'll be having one column, branch ID, HOD ID, branch ID is there, HOD ID is there, teacher ID, student ID, marks. Okay. Now suppose branch ID is EC. So just I will write here one. I don't have to write branch name now. HOD ID. Who is the HOD ID of EC? EC HOD ID, HOD ID. Suppose it's Shruti. So I will write here one. And then you will be having one more column. Sorry, I forgot here. Here you'll be having semester. Suppose semester is one, or whatever it may be. Teacher ID. Teacher ID is this. And the student IDs. Suppose this is the student IDs who are studying in one semester. Then what I can do is I will Control Shift plus. Okay, so the student ID. And suppose the master's code is something like this, 40, 50, whatever it may be. Randomly I've taken some marks. Okay, this is the marks code. Now tell me, which one do you think is better option? Scenario 1 or scenario 2?
Scenario 2.
Scenario 2 is better. Why? Why do you think scenario 2 is better? What's the benefit you are getting in scenario 2?
Because in scenario 2 we have each specific functional we have a separate table, so it is easy to maintain actually.
Okay.
So retrieval will be fast comparative to the scenario 1 table, because it have a lot of columns and it will be bit, easier for retrieval of data here.
Fine. Anyone else? Which one do you think scenario 1 is better or scenario 2 is better?
Scenario 2, definitely. In scenario 1, we are just repeating the teacher information and the student information again and again. Instead of that, we are putting them in a separate tables.
Okay, yeah. See, you both have given the correct answer. The responses are correct. Okay. Scenario 1 and scenario 2, although scenario 1 and scenario 2 both will give me the correct information and updated information. They both are correct as per the data authenticity is concerned. But while designing a database, there are many other things which you have to keep in your mind. Performance is one of the important factor. Complexity is another important factor. Okay. Here, I have created a separate branch table. Now from this, what is the use and what is the benefit I'm getting out of this is you can see here, I don't in the final score table. So the final table, okay, in the final score table. So I don't have to write, sorry, branch name. Have I mentioned branch name here? No. Just if I have mentioned branch ID, if you want to see branch name, you can come to this table and see, okay, branch name is easy. So by this technique, the first advantage is I don't have to write branch name. So I have saved the extra disk space for branch name that is saved. But in the first scenario, if you can see, so I have branch name as well. So this was the extra column. Is this clear? So just one table I have created. This is a static table. You might have heard about a static table. So this is a static table, a small table I have created, and this will act as a lookup table. So from this, you can see, okay, branch ID one means you can go to this table and you can say, okay, this is easy. Suppose if somewhere I will mention branch ID 2. So you will understand, okay, branch ID 2 means CS. If you know the SQL joins, you can join this table and you can get the information of branch name as well. Is this clear, guys? So this is the benefit of scenario 2. Similarly, you can see HOD ID. I've just mentioned ID here. I have not mentioned HOD name. But in scenario 1, you have to mention HOD name as well, right? If someone wants to see that who is the HOD name, what's the HOD name of HOD ID 1, you can come to this table. You can see, okay, HOD ID 1 means HOD name is Shruti. Okay. So that's why similarly for teacher ID, for student ID, okay, student ID is 345. You can come to this, okay, 345 student ID name is AB. You can see gender, contact, and all those things. So by this, I have saved the effort of pasting all these things in the same table. But here you can see all these things, all the information was present in one table. Okay. You can ask me that, okay, Tanvir, but here the benefit is in a single table, I can get all the information. That's correct. In single table, you have all the information. But the demerit is the first of all, and the straight demerit, which everyone would be realizing is you are utilizing more space here, and the same information is repeating again and again, again and again. Right here, if it is EC, so again this will be EC, this will be EC, this will be EC, right? Same information you're repeating again and again. But here, if it is branch ID 1, so you will understand that, okay, this is for corresponds to branch name EC. You don't have to write branch name. So like that, you have to save the disk space. And obviously the performance will be far better. Is this clear?
Sir, which one is the lookup table, sir? Score is score one or
No.
branch this one?
Lookup score is not the lookup table. A score will be your fact
Okay.
table here. The score will be your
Okay.
fact table. Okay. And these all are the dimension table. Branch is a dimension table. HOD is a dimension table. Teacher is a dimension table. A student is a dimension table. So dimension tables will just give you indicative information. Okay. And now what are indicative information? Indicative information is information about yourself. If you will ask me that, then will tell me your indicative information. So my indicative information is my name is Mohammed Tanvir Khan. I have this much year of experience. I'm working in this organization. This is my contact number. This is my email ID. This is my address. This is general information about myself. So dimensional table. So generally they will contain the indicative information. Okay, or the personal info. I will not tell personal information, but they contains the indicative information. Okay, but fact table, they will contain the information about measures or the calculations will be there. See, here I'm telling score is a fact table because you have the information about marks. So if you have the marks information, you can calculate percentage as well. Okay. Then you can calculate rank as well, that who is the topper in the class and all those things. Okay. So all the derived columns will be there in that fact tables, and all the basic information or the indicative information will be there in dimension tables. So here branch, you see, you have only indicative information. These are not dimensional tables. Sometimes it is also known as a static table. Okay. Now a static table and lookup table, they are bit different from dimension tables. Okay. A static table means static or lookup, they are more or less same. Now, first of all, let's try to understand why I'm telling branch as a lookup table. Because here if branch ID 1, if I will ask you, what is the branch name? Okay, if I will ask you, what's the branch name? So do you have branch name information here?
No.
Not present here. So obviously you will go into the branch table, this table, right? And then you will see, okay, branch ID 1 means branch name is EC. That's why this is known as lookup table. This is lookup. Branch is a lookup. Similarly, if you want to see HOD ID 1, who is the HOD name? So you will come to this table. HOD ID 1, HOD name is Shruti. So HOD is a lookup table there. Similarly, teacher is a lookup table here. Okay. And these are also known as a static table because very frequently this will change. Do you think that every month they will add some branch in the college? No, it doesn't happen. So maybe after 2 years or 5 years or 10 years, they will add some branch. That's what these are also known as a static table. Why static table? Because you're not going to modify or update this very frequently. Okay. Is this clear, guys? Hello, is this clear?
Yeah, clear.
Okay. Now, there is one more benefit of this is here this is known as normalized. This table is in more normalized form because you don't have any duplicate records here. We're not maintaining any duplicate record here. But in this format, you can see many duplicates will be coming. Suppose if address is daily, okay. So if you haven't, if you, I think you can understand that you have to write EC again and again. Then you have to copy this column again and again, right? And then Raj Kumar this will present again and again. So see, you can see in this scenario one, we're repeating the same data. Correct now. Same data is coming again and again. So no use. So you're just wasting the space, right? So you can see we have wasted how much. So at least this much space you can see we have wasted this. This was of no use. So in this case, we have used a lookup table. So just you can go and you can see, okay, fine. Branch ID, you can see in the lookup table. What's the branch ID? HOD ID, you can see lookup table. Okay, this is HOD ID. Okay. So guys, this is the benefit of fact and dimensional tables. Okay. In fact table, we will just give the references. Okay, branch ID 1. If you want to see the branch name, please go to the branch table. HOD ID 1. If you want to see the HOD name, please go to the HOD table. Okay. Similarly, teacher ID is 101. If you want to see the teacher name, please go to the teacher dimension tables. Hope this is clear. So your fact tables will contain the reference data. If you want to get more details, please join with the dimension tables. I hope you guys know about joinings and sequence and all those things. Okay, you can join with that and you can see these details. But if anyone is having problem with the joins now, so you can connect with me after the class. Okay, because I don't want to mingle both the things, otherwise we will get deviated. But if you have any confusion in those things, you can connect with me. And sometime in my SQL sessions, like those who have some confusion in their live project queries, they used to connect with me as well. But don't share your screen because you're working on your official laptop. So you should not do that. That's a violation. If you need any assistance in the query, if you're getting any syntax error, you can connect with me. That doesn't matter if you're in my SQL session or not. And I'm happy to help you. Okay, fine. So guys, hope you have understood this one, the purpose of this. Okay, so here we have removed the redundancy, duplicacy and all those things. And this is known as normalized form. This is more normalized form. Okay, now coming to the slides. Star schema, data warehouse, factor dimension tables, few foreign key joins. We will see each and every point. So what does it mean? Generally, data warehouse, this is having a star schema. Okay, and you have factor and dimension tables. Few foreign key joins. Very few foreign key joins are there. Why I have mentioned very few foreign key joins, I will tell you. Okay. Before that, tell me one thing, guys. If this is core table, if I have to join with this branch, HOD, teacher, and a student, how many primary key and foreign key joins will be here? Any idea?
One primary key.
Okay, see, and this is core. If you want to see branch name, you have to connect branch ID with branch table. So
Yeah, in branch table, branch ID is the primary key. Like that, in HOD table, HOD ID is the primary key. Teacher,
right?
Teacher ID. Student,
Perfect.
Student ID.
Perfect. So totally, if you want all the details like branch name, HOD name, teacher name, student name, so you have to join this core table with branch, with HOD, with teacher, and with student. So you are joining this core table with 4 different dimensional tables. So you'll be having 4 primary key and foreign key relationship, right? Correct, no? Are you getting my point?
Yeah, correct, correct.
You will be having 4 primary key and foreign key joins. Okay. So that happens in a star schema, that you have very few foreign key joins. But I will show you when I will go to the Snowflake schema that you'll be having more primary key and foreign key joins, and what is the purpose, how it is beneficial. We'll look into all these things. Okay. And I will come to this why it is telling data warehouse. I will come after some slides, then I will make you understand this. Fact and dimension tables is present in a star schema and a Snowflake schema both. You see, this is the structure of fact and dimension table. One fact table will be having multiple dimension table. Okay, and this fact table, why it is having multiple dimension table? Because we don't want to store all the information in one table. Why we don't want to store all the information in one table is because that will be like duplicate data. We are repeating the same data and again and again. And I think what I have shown you right now, you must have realized that, right? Because here we are repeating the same data again and again, that we don't want to do. That's why I splitted that in multiple tables. Hope this is clear, guys.
Yeah, yes, clear.
Clear.
Sure, today I'm forgetting all the shortcuts. Something happened with me or what? Yeah, the shortcut. Yesterday I have done this in this table format. Today I forgot what was that shortcut I have used. Okay. Okay, so this is the purpose. If someone asks you in interview that why you in an ETL project or if you're designing a database, data warehouse, why you have fact and dimensions. So hope the answer is clear that we don't want to maintain all the data in one table because they are getting duplicate, and that's not a normalized form, but we're splitting the data in multiple tables. So through that we are avoiding the duplicates, and that's more normalized and performance will be better. But of course, we have to join multiple tables. That's a headache or overhead. But in SQL, we have that option and we can join and we can get the required information. Now, this is again like more realistic view. We have a fact table. The name is revenue. You can see, and please try to correlate this with the college database, what we have seen right now. We have a revenue table. This is a fact table here. We have dealer ID, model ID, branch ID, date ID. If you see the first 4 column, guys, dealer ID, model ID, branch ID, and date ID. So in revenue table, from these 4 columns, you cannot get more information that what's the dealer name, what's the model name, what's the branch name, and which date it has happened. But this is just giving you IDs. Okay, and then you have units sold and revenue. These are the derived columns, units sold and revenue, or you can tell these are the measure columns. Okay, because this is giving you transactional data, transactional information. Okay. So one more difference is there. Dimension will give you indicative data or indicative information. Okay, and fact will give you transactional data or transactional information. You guys, please make a note of all these questions. I'm telling you. Okay. Believe me, in interviews, if you're going to crack, okay, if you're going to face, so 90% or 95% of questions what I'm sharing you will get from this only. Now those who have attended interviews, maybe they would be realizing this as well. So please make a note of the questions what I'm telling. Okay. Now dealer ID, if you want to see that, no, I want dealer name as well, I want dealer contact number and all those things, then you have to connect this dealer ID with the dealer. So it means you have to join revenue table with your dealer table. Okay. And what should be the primary and foreign key here? More guys, what should the primary key and foreign key? You want to join revenue and dealer table?
Dealer ID is the primary key.
Yeah, you have to join through dealer ID. So these 2 tables will be joined, and then you can get the information about dealer name, dealer contact, right? So through this way, we have saved the disk space, and we have avoided the duplicate as well. Similarly, if you want to get the branch name, address, and country, you have to join revenue and this branch dimension table through branch ID. You can see branch ID is present here as well. The branch ID is present here as well. So here branch ID will be primary key and foreign key relation. You can join these 2 tables. Okay. Now in this, suppose similarly product, you can join with product. I think product ID. They have not mentioned here product ID. Okay, but you'll be having a product ID column here, and you can
model ID. Model ID.
Model. Correct. Very good. They have mentioned model ID. Correct. Very good. So from model ID, you can join and you can get the information, product name, and all those things. Similarly, you have date dimension and you can join. So guys, this is the purpose that why we have fact and dimensions. Okay, but you should be strong in SQL. That's what I'm telling you from beginning of this session. If you want to work in ETL project, or if you're working, so try to groom yourself on SQL. Okay, so try to groom yourself. Try to learn more advanced SQL concepts. That will fit you. Fine. So this was all about dimension and fact table, and this is known as star schema. You see, this is a star schema. Why this is star schema? It resembles little bit like a star, no? Little bit like a star, like this structure is going. Okay, so this is like a star schema. That's why the name is the star schema. Okay, then we will see what is a snowflake schema. But before this, any question on this? Please come on, ask me. Even if that is a silly question, don't be shy. Is this clear?
Star schema
I have a
and
question.
fact table same, sir, but the name it's same.
Sorry, can you come again?
Star schema and fact table both are same, sir. The name itself change. That's it. No?
See, a star schema. Just a minute, just a minute. It is not there like in stars, or do one thing. Okay, let me complete a snowflake schema as well. Okay, I think that it will be easy to understand. But to answer your question, it is not like that fact will be in a star schema only. Fact is present in a snowflake schema as well. Dimension is present in a snowflake schema as well. Okay. So see, like there is a birthday celebration. Okay, if there is a birthday celebration. So I will provide you balloons and other things what are used to decorate. Okay, I'll provide all the things to 2%. That okay, you have these balloons and all these things. What all things are used to decorate. So it is not necessary that they both will decorate the hall in the same way, right? They will be decorating maybe in different ways. So the ingredients are same for a star and snowflake schema. The material is same, but the way we are decorating is different, and that's why the name is a star and snowflake schema. Otherwise, the concept of dimension and fact is same both way. In the star and snowflake, both we have dimension and fact tables, but how we are decorating it, how we are arranging it, because of that you have named the star schema and snowflake schema. Okay, we will see that snowflake schema, then that will be more easy to understand. Now coming to a snowflake schema, generally design database.
Tanvir, I have a doubt.
Oh yeah, sure. Just tell me.
Yeah, in star schema, in fact table point of view, can we say like dimension tables are lookup tables, because we are getting the information of
Correct,
dealer
correct.
with the dealer ID,
Correct. So here
and
your
again we are
dimension
getting
tables
into
will
the
be your lookup tables. You are correct. Absolutely. Dimension tables will be your lookup table. But you cannot tell, this table is confusing me. This is of no use. Delete this one. Okay, but you cannot tell. Okay, here your branch, HOD, teacher, and student. These are your dimension tables, right? But you cannot tell that these are my static table as well. Or else, sorry, I told the wrong way. Here, this is a static table, but always you cannot tell that dimension tables are a static table. It is not necessary that your dimensional table will be a static table. Before that, let's understand what is a static table. Static table and lookup tables. Static tables means the tables which are in which the records are inserted, updated at not at a very regular interval. Okay, then they might be, the data will be updated after 3 months, after 6 months, or after a year, after 2 years, like that. So those tables are known as static table. Okay, they are also known as lookup tables. Okay, they're also known as lookup tables. Then you have a concept of dimension table. Dimension tables will give you information, basic information, like here HOD, this is a dimension table. The student, this is a dimension table. Okay, so dimension tables are also known as lookup tables. Is this clear? So if I'm telling lookup table, so they might be a static table. If I'm telling lookup table, they might be dimension tables. Is it fine? Okay. Now, can I tell all the dimension tables as static table? Can I tell? Can I tell that, okay, this is student table? Okay, this is a static table. No, you cannot tell, because maybe if you go back, if you think about, like suppose if you think about your college school days. In the school days, it happens when the session is started in April. Session used to start by April, but sometime you will see that, okay, a new student has admitted maybe in the month of May, or sometime it happens in June as well. So you never know that this table can be updated very frequently, right? So that's what dimension tables. Sometimes dimension tables are updated very frequently. Sometimes they're not updated very frequently. Okay. So that's why it is not necessary that dimension tables, you can tell them as static tables. Okay. Because dimension tables, you never know the frequency at which it is getting updated. Sometimes the dimension tables you will see it is getting updated after every week. So in that case, can you tell that, okay, this table is a static table? No, you cannot tell. Okay. So that's why you cannot tell all the dimension tables as static tables. Okay. But the opposite is right. You can tell your static table as dimension tables. Okay. All the static tables are your dimension tables because you are joining that with the main table, with the fact tables to get the useful information. Is this clear?
Yeah, clear.
Any other question? No. So
So is
static.
there any when we entered into the project, is there any indication or any
Sorry.
any indication on lookup tables or static tables? These are the tables we have to.
They will tell you. You will be
consider.
having
Yeah.
a document where it will mention that this table is a static table, this is a dimension table, this is a fact table. All the information will be there. But why I'm teaching all these things, you should know that what are the properties of this. Okay, if it is a static table, it means there should be a point in your mind that, okay, this table will not be updated frequently. Maybe after 6 months, maybe after a year, they will update this. Okay. Dimension tables, maybe this can be updated frequently, or maybe it will not be updated frequently. That depends. You have both the option in dimension table. If someone is telling you dimension table, someone is telling you that all the dimension tables are static tables. Is it correct?
No.
No.
No, because you never know about dimension table when it will be updated. Maybe daily on daily basis also it can be updated. That is also possible. Okay. So that's why I'm not telling that all the dimension tables are static tables. No, this is incorrect. But yeah, all the static tables are your dimension tables. Static dimension, what I've written here. But all your static tables are your dimension tables, and all the static dimension tables are your lookup tables because you are joining with that to get the useful information. Any other question?
Okay. Clear.
Okay, perfect. And this is example of your star schema. Okay, so then we have a Snowflake schema, general design database project. Your star schema will be generally in your data warehouse project, but again, that's not a hard and fact rule. That okay, if you are working in data warehouse project, it means you are loading historical data, so it will go for a star schema only, or a star schema will go only for data warehouse. No, it's not like that. Many database project where you are storing transaction data, where we are having that star schema. I think few of you who have missed the day before yesterday session, so you might be getting confused with database and data warehouse, but we have discussed in detail. So please go through the recordings, guys. Okay, that's very important concept because that will come again and again. Okay. So it is not like that the star schema will always be implemented in data warehouse projects. No, no. The star schema you can implement in database projects as well. Okay, so you have full freedom. Don't think that okay, this is star schema, so this can be implemented only in data warehouse. No, it's not like that. You can implement this in database projects as well. But generally, star schema, star schema are used in data warehouse project. What is the reason? We will discuss on that. Okay. Similarly, but Snowflake schema, very rare, rarest of the rare scenario, 0.001%, you will find a Snowflake schema in data warehouse projects. Okay, most of the time, your data Snowflake schema is implemented in database project or project in which you have daily transactional data. There we used to implement the Snowflake schema. So here we don't have very strict formula that okay, this is star schema, no? So this will go in data warehouse project. No, it's not like that. You can implement your star schema in database project as well. Similarly, a Snowflake schema, generally this will go for database project where you have daily transactions. Okay, we will see that why I'm telling that Snowflake schema. We implement database project. What is the reason? Okay. Now in Snowflake schema, you have a concept of fact, dimension, and sub-dimension. You see, this is the keyword here. In a Snowflake schema, you have a concept of sub-dimension, and that's the reason you have a Snowflake schema. We will see what is this sub-dimension. But if you see here in star schema, I have not mentioned anything about sub-dimension. I have just mentioned fact and dimension tables. But Snowflake schema, you have fact, dimension, and sub-dimension as well. And this is the reason that we have the Snowflake schema. Okay, we will see what is sub-dimension. Any questions so far? No question. See, this is a Snowflake schema. Okay, now try to understand it. It's very simple. First of all, forget about this sub-dimension. Forget about this sub-dimension. Sub-dimension. Okay, in your mind, try to remove this. First of all, this sub-dimension. If you will remove all this sub-dimension, so you are left with only this fact and this 1 dimension, 2 dimension, 3 dimension, 4 dimension, 5 dimension, right? And this picture will be exactly same as this picture. Is this clear?
Yeah, clear.
Correct,
Yes,
no?
yes.
So from this picture, if you remove all this sub-dimension, so the remaining picture or diagram will be exactly same as this. Okay. So here the difference is in this dimension table, again, I have splitted this in 2 sub-dimension. This dimension again is split in 2 sub-dimension. And again, this dimension is split in 2 sub-dimension. You can ask a question that it is like we are going to split this only in 2 sub-dimension. No, you can split in 3 sub-dimension as well. You can split in 4 sub-dimension as well. That depends on the complexity of the project and how much grain to what grain you want to go. It depends on that. Is this clear? Okay. Now we'll see that why is this. So that's why this is known as Snowflake schema, because you are going at a more granular level. You're going at a more detailed level. Why I'm telling that you're going at a more detailed level is I will show you with this diagram. Now, same table, what we have seen here. We have seen this table, and I was telling you that this is an example of a star schema. So let's try to understand it now. Same table, fact table revenue, you have dealer, date dimension, product dimension, and branch dimension table. But to this dealer, further I have splitted this in 2 separate tables. Okay. So location ID, I'm giving a region as well, because from this table, if someone will ask me that, okay, you have location ID, suppose location ID is 234, then someone can ask me to tell the region. That's in which region? It's in Asia, Europe, Australia, US, where it is. So that's why I thought that, okay, he is correct. I have just mentioned location ID, but from location ID, the location region is not clear. So let's make one more table. So I have split this in one more table. So this table will give you location ID and region as well. Similarly, here country ID is there, but country name is not present in this dealer table, right? So I have created one more dimensional table. So this will give me country ID and country name as well. Okay, is this clear, guys? You understood this?
Yeah, clear.
Yeah. Now I have a question. You can ask me that. Okay, then we sorry. Tanveer, we have created a separate location table and you are showing me the information about region that, okay, particular location ID, suppose 234 is the location ID. And from this table, I cannot get the region details. So you have created a separate table and this will give me the region details as well. But why you cannot add one more column region here? Why you're going separately, you're creating a separate table and then you're keeping that location ID and region. Let's create one more column here and name it as a region. Okay. So why I have created this separate? Who will answer this? What is the reason for that?
Again, reputation will come into picture.
Perfect. Repetition will come
For
into
location ID.
picture. Correct. Repetition will come into picture. To avoid that, I have created a separate location ID and region. Okay. Similarly, country ID and country name is there. To avoid the repetition of the record, I've created a separate table here. So now if I will stop, if I will not show you these 2 dimension tables, so now I am showing you these 2 dimension tables. So you are getting information at a more grain, more detailed information you're getting from this. But if you go for this, you're not getting more detailed information because I'm not showing you that location region. I'm not showing you a country name. But here you're getting more detailed information. You have that region name as well. You have country name as well. Now, suppose in that country you want to know the state. Again, you can split this in two-dimensional table. Again, you can split this. Now you can get country name as well. If you want to know the district name, again, you can split it function further. Okay, is that clear? Hello, is that clear, guys?
Yeah.
Is that a
Yes, yes.
grain of fact?
Sorry.
Is that a grain of fact table?
Yeah, that's a grain. So here the grain is country name and region, and here the grain was your country ID. So, but from this I'm not getting country name, but here the grain is I'm getting more detailed information. Now I can see the country name as well. So we are getting more detailed. So that's why someone asks you that why you want to design your project in Snowflake schema, or maybe they can ask that why someone wants to go for Snowflake schema. So the very simple answer is whenever you want more detailed information or information at a more granular level, so we used to design a Snowflake schema. That's the answer. Okay,
How can
similarly,
we define grain of fact?
how can we?
Define grain of fact. If
Okay.
someone asks in an interview,
Sure. You see, first of all, let's try to understand what is grain or what is granular. Okay. Grain means how detailed information you want. Okay. Suppose if you are asking, okay, Tanvir, introduce yourself. I will tell, okay, my name is Tanvir and I have this much year of experience and I work for this company and all this. Then maybe he can ask, okay, tell me your education qualification. I'll tell, okay, I have done BTech from this college and this is my stream. Okay, that's the one thing. So now he has more detailed information apart from a professional life. He has educational background as well. Then he can ask me that, okay, tell me how much marks you have scored in each semester. I will tell, okay, I have scored this percentage in each semester. Now he's having more detailed information. So he's giving it a more detailed information, right? Then again, if I can ask, okay, tell me in second semester in this subject, how much you have scored. You're understanding, guys? So he is getting more detailed information about me. So he's going at a more grain, okay, right? Or coming to address, someone will ask me, what is the nationality? India. Okay, tell me your state. Okay, this is my state. Okay, in that state, tell me that city. This is my city. And tell me that address. This is the address. Tell me the pin code, house number. So he is getting into more detail. So grain means how much detailed information you are getting. So grain of a fact means the lowest level of information, the detailed level of information what you are getting, that's a grain of fact. How much at a granular level you are getting, that's a grain of fact. If someone is asking you what is measures in fact, so measures in fact means the columns which are giving you transactional data information or the derived column. So here the measures will be your units sold, revenue, because this is giving you information about the transaction what has happened. Okay, is this clear? Have I answered your question?
yes, clear.
Clear. Okay. So guys, this was all about star schema and snowflake schema. So to summarize this, star schema and snowflake schema, they both have fact and dimensional table. I think same thing I mentioned you earlier as well. They both have both fact and dimension table. But in Snowflake schema, to each dimension, you again have sub-dimension. So this is sub-dimension. This is again sub-dimension. So now you have two sub-dimension tables to this dimension table. So you why? Because you want to see data at a more detailed level. That's why you have two sub-dimension here as well. And that's the reason when you want to go in more detailed, you want a Snowflake schema. Now you can ask me a question that Tanvir, I want to add this region and country name in this table as well. I don't want to create a separate sub-dimension table. Okay, fine. Create it here. Okay. Similarly, this fuel type, create it here only. Then this will be your star schema, no issues. But the demerit will be you are repeating the same data again and again. Okay. So that will be you'll be using more disk space, performance will be less and all those things. So guys, this was the reason why you go for Snowflake schema. Any question in general apart from this? Now you understood the concept of sub-dimension. Okay. Fact and dimension tables over there. Here you have few foreign key joins, but the Snowflake schema you'll be having more foreign key joins, because here you have to join. First of all, you will join this fact to this, then this will be joined to this. So here you'll be having 3 joins, but here you'll be having only 1 and this 2 join. So for this you have 2 joins, for this you have 2 joins, for this you have 2 joins. Totally how many joins? 1, 2, 3, 4 joins. But here how many joins are there? This will be 1 join, this will be 2 join, 3 join, 4 join, 5 join, 4 join, 5 join. Here you'll be having 5 joins, right? Or 6 join, because this will be joined to this and this will be joined to this. 6 to 7 joins will be present here. So that's why I have mentioned here you have very few foreign key joins, but here in Snowflake schema you'll be having more primary key and foreign key joins. So, but you should know the reason that why we have the concept of Snowflake schema. Always ask this question, that why we have this concept, why we have this technology, why nowadays we have Python, why we're not continuing with Java. So all these things should come to your mind. Okay. Any question on star and Snowflake schema, guys? Please ask me. Anything you want me to repeat?
Sir, the primary key always exists in dimension table only, right?
Uh,
Always exist in fact table.
you see, you are correct. Actually, the primary key will be in dimension table only. Actually, this fact table, no, these are also known as reference table, because actually they don't have their own entity. If you see this fact table, they don't have their own entity, because this is dependent on this dimension table. If I will tell you that I will not give you this dimension table, so this fact table is giving you information. No, unit sold and revenue is there, but you don't have an idea that what's the dealer name, what's the model ID, when this unit was sold, on which date it was sold, which branch, right? So actually that primary key is present in dimension table. You are correct. Here also it is present. But those primary key you have to use in fact table as well. Then only you can get the detailed information. But primary key is present in dimension table. Is that clear?
Sir, okay, but here in sub-dimension tables are the also then I want detailed information about the country. Then in this case, country ID is the foreign key. This sub-dimension is the primary key.
Sub dimension will be primary key. Correct. So here your sub dimension. No, you see, actually what will happen? Don't get confused that okay, which one is primary or which one is foreign key. Think like this. This dimension table, first of all, I'll create this dimension table. Okay, so in this dimension table, dealer ID is your primary key. Is this clear? Now I have to, now in this fact table, I have used this dealer ID. So this dealer ID, why I have used this in fact table? Because this will be useful to join with this. So this dealer ID, I'm using this in this table because I know this is already present here. So this is the foreign key. Okay, and this is the primary key. So I'm joining with this. Okay, so this is like primary key and this is foreign key. Similarly here, I'm using this country ID here. Why I'm using country ID? Because already country ID was present here. But here I want to add the same country ID because this will give me the country name. So here in this table, country ID is my primary key. And here in this table, the country ID is a foreign key. Okay, because I want to join this and I want to get this information. So first of all, in any project, you will create this dimension table. Okay, then as per this, you will create fact. And then as per this, you will create dimension. So your parent table is dimension table. And all the tables what you're creating on top of this, those might be your fact table or your sub dimension table. Now the same key is present in those tables, so those keys will be known as foreign key. Like here, dealer ID is present here as well, and it's present here as well. You can tell me that, then we know dealer ID is present in fact table as well. Then I'm telling you, I will tell this dealer ID in fact table as a primary key. You cannot tell this is a primary key because dealer ID term was given by this dealer dimension table to this. This fact is just using this. This fact table is using this dealer ID. This dealer ID is not its own property. That's why this is a foreign key. Similarly, in this sub-dimension table, the country ID, you are using from this dimension table. So that's what this is a foreign key here. Okay. And this country ID is a property of this dimension, dealer dimension table. So this is a primary key of this table. Is it clear?
Okay, understand.
But in dealer
In this
table,
case,
in
but
dealer table, dealer ID should be the primary key, right?
Which table? Sorry, which table?
In dealer table, dealer ID should be the primary key, right?
Dealer table. In dealer table, dealer ID is the
Dealer ID.
primary key. Yeah. But this dealer ID in this revenue table, it is not a primary key. This is a foreign key in this revenue table. Okay. because this dealer ID is the property of this dealer table. First of all, this was created. This revenue table is just referring to this. So that's why this is a foreign key. Is it clear now?
So in country table, country ID, the country ID would be the primary key, right?
No. Don't think like that. Okay. Don't think that is going in that way. No, it's not like that. I think you're thinking that, okay, this is child, this is parent, then this is grandparent. No, it is not like that. Okay. Which table is created first? Here, if you see this country, dealer, and revenue, which table is created first? First of all, you have
Dealer
created
table
dealer
create
table.
first.
Dealer table was created first. So this dealer ID is the primary key of this dealer table. Location ID is the primary key of this table. Country ID is the primary key of this table. Okay. Now you are using this dealer ID in this revenue table. You are using this dealer ID in this revenue table. So this dealer ID is not a property of this revenue table. Actually, this is present in dealer table. So you're using this in revenue table. That's why you're referring this. And that's why this is a foreign key. Similarly, you thought here that I should create one more table. You should give me more detailed information about country name, right? That's why then you design one more dimension table. Okay. And this dimension table, you have used country ID. Why you have used country ID here? Because you know that already in this tier table, parent table, you have country ID. And then you have designed this table and you're given country ID and country name. So actually this revenue table and this country, they both are child of this parent table because they both are created after this dealer table. That's why this country ID in this country table is a foreign key to this dealer table. Similarly, this dealer ID is a foreign key to this dealer table. Don't go by this hierarchy that, okay, this is a child, this is a parent, and this should be grandparent. It's not like that. Always you have to see which table was created first. That will be for primary key. And then the tables which are created on top of that, there will be a foreign key. Is it clear?
Okay.
Are you sure this is clear? You want to repeat? I will repeat this.
Again, I have a doubt here.
Yeah.
In the data table or any table, can
Hmm.
we have like more than one primary key on a table?
Yeah, see,
If it is not a composite primary key.
I understood from where you are coming. I understood that. Okay, let me create one table. And this will be more clear. Personal data. Suppose I created a table personal data. Okay, you have name, you have Aadhaar, you have PAN, voter ID, and you have location. Okay, suppose my name is V. I have some Aadhaar number. Okay, I have some PAN number. I have some voter ID number. Okay, and suppose location is Delhi. Now, similarly, you'll be having some more data. In this table, tell me what is your primary key?
There are possibility of 3 primary keys
Correct.
can be.
This can also be primary key. This can also be primary key. This can also be primary key. But when you are designing this table, you have to use any one column as a primary key. You cannot keep 2 columns as a primary key. I'm not talking about composite primary key concept, right? So while designing table, you will mark either Aadhaar as a primary key, you will mark PAN as a primary key, or you can mark voter ID as a primary key. But they both are suitable candidate for a primary key, correct? So from this, what I want to tell you is, it is possible that in a table you can have multiple columns who are suitable for a primary key, but of course, you're going to make any one column as a primary key. Okay, you're going to make only one column as a primary key. So similarly, in this, you have this dealer ID, location ID, country ID, they both are primary key, but you have to make any one as a primary key. Okay, if it is dealer ID, you can join with this dealer ID table and you can get the information. Similarly, location ID, here it will be country ID. This is primary key here. You can join with this and you can get the information. Is it clear?
Okay.
No, not clear.
Sir,
So in dealer table, we explicitly defined dealer ID is a primary key, right? Even though location ID and country ID is there, right? In the dealer table. So in that case, only dealer ID would be the primary key for the dealer ID, right? So
Mhm.
if country ID is referring in some other table,
Mhm.
will that be termed as a foreign key in other table? Because it is it's not nowhere mentioned in the previous table as a primary key, right?
Can you repeat again? Sorry, can you repeat?
The dealer table, we
Mhm.
explicitly mentioned dealer ID is a primary key, right?
Correct, correct, correct. Very good.
So that means location ID and country ID are not the primary keys.
Perfect, perfect. Very good. This is not the primary key of the
They're
table.
eligible,
Correct,
but they are not
correct,
the
correct,
primary keys, right? So
correct, correct, correct.
so we're another table is joining this dimension table, which is country table. So country ID in that table would be the primary key, right?
Okay, you are correct. You are correct. That if you are designing this table, you are correct. If you're designing this table, so in this table, country ID will be the primary key because already in dealer table, I have given dealer ID as a primary key. So country ID cannot be a primary key of this dealer table. But in this country table, country ID will be primary key. That's what you're mentioning, right? I think that's what you have mentioned, right?
Yeah, yeah.
You are correct, totally correct. But what I'm trying to tell you is why you have created this country table. First of all, tell me this. What's
I
the
want
reason?
more detailed
Get that,
information on country.
get that,
To
yeah,
get
yeah.
more
Get
detailed
extra
information
information.
about country so that you can get country name as well because here only country ID was present, right? But you want more detailed information. Correct? No, this is correct because you want to know country
Yes,
name
correct.
as well. That's why you created this country table. Very good. This country table was created on top of which table? On top of this dealer table? Because in this table you have country ID. So what all country ID are present here, same ID you will use here. Correct? If you see this information, what I have shown you here. So here I have used this branch ID and branch name. Why? Because branch ID was, I think I'm not on branch ID here. I'm not mentioning. Okay. Or maybe HOD ID and HOD name. This HOD ID was present here 1, 2, 3, 4, 5. This HOD ID is present 1, 2, 3, 4, 5. Can I keep HOD ID here as this number or this number or some other number? No, I cannot keep these numbers. Why I'm using the same number which is present here HOD ID? Because this HOD table is created on top of this table, right? On top of this table. Similarly, here country table was created on top of this table. So what all country ID is present here, same country ID I'm using here as well. So this country ID I'm referring to this from this table, right? Right. So that's why they both are joined with the primary key and foreign key. Okay, primary key and foreign key. But you are correct. This country ID is a primary key of this table. And this country ID is not a primary key of the table. Then why you're telling that this country ID is a primary key of this and this is a foreign key? I'm not telling from that perspective. I'm telling that this
So,
country ID is written on top of this dealer table. First, this table was
okay.
there. Then
That
you have
means
created this
country ID
table.
which are not present in dealer table may not be present in country, right?
Correct, correct.
Country
Yeah,
table.
yeah. So that has been created on
Okay,
top
okay.
of that. But if you're talking technically, that then will tell me which is the primary key in country table. So answer is country ID. Then will tell me which is the primary key of dealer table, dealer ID. Then tell me why you're telling that country ID is the primary key and this is the foreign key. No, not from that perspective. From designing perspective, country ID was first of all created in this data table. Then you have created country ID in this table. So in that way, this is primary and this is foreign key because you're referring this. Okay, fine. But if you
Okay,
create this table, obviously you have to give country ID as a primary key. Okay.
okay,
Any other
okay,
question,
clear,
guys,
clear.
on this?
Sir, dimension table only consists of primary key and fact table only consists of foreign key. This statement is right, sir.
Dimension table only consists of primary. Correct, 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 correct. Very good, very good. Dimension tables you'll be having primary key and fact table you'll be having foreign key which you will use. You see why I've used dealer ID here because same dealer ID was present here. So I'm copying this from this dealer ID. So this is a foreign key here. Okay, this is a foreign key. But if someone is asking that fact table doesn't have any primary key, no, you can add a primary key to fact table as well. Okay, we have primary keys in fact table as well. They're different concept altogether for that. But I'm not telling that in a fact table you don't have any primary key. No, we have primary key in fact table as well. But if you are correlating dimension and fact, so the IDs what you're using in fact table, they are coming from dimension tables. They don't have their own ID. Tell me, dealer ID is the ID of revenue? No, this is not the ID of revenue table. This is the dealer ID of dealer table. Similarly, this model ID, this is the ID of this product table. Branch ID, this is the ID of this branch dimension table. Okay, is this clear? Is it clear, guys? Or you guys?
Yeah, clear.
Clear? So when I will teach you that SCD type 2, no, so that will become more clear from that. Okay. Yeah.
I will ask you in a personal window.
Okay,
I have
no
a
issues.
doubt.
No, if
It's
you
not
okay,
related to this topic. Yeah.
okay, if you want to ask, you can ask, no issues. But if you want to call me
Yeah.
personally, you can ask, no issues.
Yeah. Yeah.
Okay, fine, no problem. Any other question, guys? A star and
One-
Snowflake. Yeah.
Yeah, one quick question. Like if we are adding any new products in a dimension table, will it affect other tables, the fact tables accordingly, or it will not?
We are adding a new product in this table. Correct. Okay. If you are adding a new table in this product table, so obviously you'll give a new product ID, right? Product name will be there, model ID will be there, variant ID will be there, correct? So if you're adding a new product here, so that product ID should be present in your in revenue you have. Okay, so for that product you'll be having a model ID. Now that model ID should be present in your revenue table as well. That should be present here as well. Now you might be thinking that how it will be done. So you have to run a job. So when you will run the job now, so this fact table, revenue table will pick automatically from this dimension and it will populate here. Okay.
Okay. Yeah.
To any dimension table. Suppose we want to add a new dealer ID. So you will add this dealer ID in this table. Then you don't have to add that in fact table. But when you will run the job will pick that new dealer ID from this dealer table and it will populate that in fact table. Automatically this should happen. Okay, is it clear?
Yes.
Any other question? So guys, are you sure you understood this star schema, snowflake schema, why we have a star schema, why we have a snowflake schema, why we are not keeping all the data in one table, why we are creating separate tables, and how we are joining and all those things? Understood?
Yeah. Yes. Clearly. Yeah.
Okay.
Yeah, understood.
Yeah.
Still, if you have any question, we can take it tomorrow and we can discuss further on that. Then I was having few differences in star and snowflake schema. So this is very important. I thought of completing this today, but no issues. We will see this tomorrow. So when we will have this discussion, no, so we will get a more clear understanding of the difference between a star and a snowflake schema. And please come up with more questions because this is really a complicated topic of entire database or data warehouse concept or entire ETL world. Okay, fine. Okay, guys, thank you for joining today. Let's connect tomorrow. Take care. Oh, sorry, connect on Monday, right? Because today is Friday. So connect on Monday. But before coming to Monday class, please revise this again because we have to continue with the star snowflake schema differences. Okay. Thank you. Take care. Bye.
Thank you. Bye.
Thank you.